For centuries, humans have gazed at the night sky, marveling at the planets that dot the vast expanse of the cosmos. Among them, one world has captured our imagination more than any other: Mars. Unlike the distant gas giants or the scorching surface of Venus, Mars presents itself as a familiar yet mysterious neighbor, a world that, in many ways, mirrors aspects of our own. With its vast deserts, towering mountains, and polar ice caps, Mars has long been a source of speculation, wonder, and curiosity. The idea of life beyond Earth has fascinated scientists, philosophers, and storytellers alike. From ancient civilizations attributing divine significance to the Red Planet, to modern science fiction authors envisioning thriving Martian civilizations, Mars has played a central role in our cosmic aspirations. But while early theories of an advanced Martian race have been debunked, the possibility of microbial life, past or present, remains an open question. More intriguingly, as our technological capabilities advance, the question is no longer just about whether life exists on Mars, but whether life could thrive there in the future. Beyond the search for extraterrestrial life, another idea has taken center stage in recent years: human colonization. As Earth's population grows and our planet faces increasing environmental challenges, the notion of establishing a second home for humanity has gained traction. Could Mars be that home? The thought of humans setting foot on another planet, not just for exploration, but for long-term habitation, has shifted from the realm of fantasy to a potential reality within our lifetime. Space agencies like NASA, ESA, and Roscosmos, along with private enterprises like SpaceX and Blue Origin, are actively working to make interplanetary travel a possibility. Ambitious plans for crewed missions, permanent settlements, and even terraforming strategies have ignited discussions across scientific communities and the general public. With each passing year, new discoveries and technological breakthroughs bring us closer to answering the fundamental question: can we, as a species, colonize Mars? And if so, how would we accomplish such an extraordinary feat? However, before we dream of Martian cities and self-sustaining colonies, we must confront the immense challenges that come with space travel, survival on an inhospitable planet, and the long-term viability of an off-world society. What would it take to get there? How would we sustain ourselves? And, perhaps most importantly, what does the future hold for humanity if we become a multi-planetary species? This discussion is not just an exploration of the technical hurdles, but also of the human spirit, our innate desire to explore, to push boundaries, and to ensure the survival of our civilization beyond the limits of Earth. The journey to Mars is more than just a scientific endeavor. It is a testament to our ambition, our resilience, and our unyielding quest to seek out new frontiers. Mars has fascinated humanity for centuries, but it was only in the 20th and 21st centuries that real scientific exploration of the planet began. From the earliest telescopic observations to modern robotic missions, each discovery has only deepened our interest in the Red Planet. The allure of Mars stems from its similarities to Earth, its potential for past life, and its promise as a stepping stone for human space exploration. One of the most significant contributors to the growing interest in Mars is the success of robotic exploration missions. The twin Viking landers of the 1970s provided the first close-up analysis of the Martian surface, revealing a barren yet geologically intriguing world. Although these missions did not find direct evidence of life, they set the stage for future exploration by proving that landing and operating on Mars was possible. The Mars Pathfinder mission of 1997 introduced the world to Sojourner, the first rover to traverse the Martian surface. This small, six-wheeled robotic explorer demonstrated that mobile exploration was feasible, paving the way for larger and more sophisticated rovers like Spirit, Opportunity, Curiosity, and Perseverance. These missions have transformed our understanding of Mars, uncovering evidence of ancient riverbeds, organic molecules, and subsurface ice. Findings that suggest Mars may have once been habitable. Private organizations and commercial entities have also played a crucial role in popularizing the idea of Mars colonization. The Mars Society, founded in 1998, advocates for human exploration and settlement of the planet, hosting annual conventions and Mars simulation experiments in remote locations on Earth. Another ambitious project, Mars One, aimed to establish a permanent human colony on Mars, though it ultimately faced financial and logistical setbacks. NASA has placed Mars exploration at the forefront of its long-term goals. The agency's Artemis program aims to return humans to the Moon as a stepping stone for Mars missions, while its Mars Sample Return mission is designed to bring Martian soil back to Earth for detailed analysis. The Perseverance rover, which landed in Jezero Crater in 2021, is actively searching for signs of past microbial life and testing technologies that could support future human missions. SpaceX, founded by Elon Musk, has arguably been the most vocal proponent of Mars colonization in the private sector. Musk's vision of making humanity a multiplanetary species hinges on the development of the Starship rocket, a fully reusable spacecraft designed to transport large numbers of people and cargo to Mars. SpaceX has conducted multiple test flights of Starship prototypes, with plans to refine the vehicle for interplanetary travel in the coming decade. Public enthusiasm for Mars exploration has also been fueled by popular culture. Films like The Martian, 2015, based on Andy Weir's novel, have brought realistic depictions of Martian survival to the mainstream, while TV series like For All Mankind explore alternate histories of space exploration. Books, video games, and documentaries continue to inspire new generations of scientists, engineers, and space enthusiasts. Despite these advances, there are still many unanswered questions. How can we sustain human life on Mars? What challenges will settlers face in terms of health, psychology, and resource management? And perhaps the most profound question of all: if we do establish a presence on Mars, what will it mean for the future of our species? These questions drive ongoing research and keep the dream of Mars exploration alive. As interest in Mars grows, so too does the commitment to making human exploration a reality. Governments, private companies, and international partnerships are investing in the technologies and infrastructure necessary for a future Mars colony. The journey to the Red Planet is no longer a matter of if, but when. A journey to Mars is one of the most formidable undertakings in human history. The challenges extend beyond distance, involving survival, technology, and human resilience. These include cosmic radiation, exposure. Prolonged exposure to solar wind and galactic cosmic radiation increases cancer risks and can impair cognitive functions. Shielding technology and protective habitats will be necessary to ensure astronaut safety. Communication delays. Due to the vast distance, signals from Mars to Earth can take between 3 to 22 minutes one way, making real-time communication impossible. Astronauts will need to rely on AI and autonomous systems for decision-making. Hostile living conditions. Mars has an extremely thin atmosphere, rendering it incapable of supporting liquid water on the surface for extended periods. Temperature fluctuations and dust storms pose additional threats to long-term survival. Resource scarcity. Water, oxygen, and food production will require closed-loop life support systems and in-situ resource utilization (ISRU) strategies to extract necessary materials from the Martian environment. Physical and psychological strains. The isolation, confinement, and reduced gravity of Mars can have profound effects on both physical health and mental well-being. Maintaining astronaut morale and fitness will be a major challenge for long-term missions. Overcoming these challenges will require revolutionary advancements in aerospace engineering, biotechnology, and planetary sciences. The technology that sustains human life on Mars may also lead to groundbreaking innovations that benefit Earth, from medical advancements to new energy solutions. Despite the risks, the pursuit of Mars colonization represents humanity's greatest step toward becoming a truly interplanetary species. Selecting the right location for human settlement on Mars is critical for long-term survival. Scientists and mission planners have identified several potential sites, each with its own unique advantages and challenges. The Martian poles contain vast amounts of water ice, making them a promising location for human settlement. Water is essential not only for drinking and irrigation, but also for producing oxygen and hydrogen through electrolysis. The presence of ice would significantly reduce the need to transport water from Earth, making colonization more feasible. However, the poles experience extreme cold, with temperatures dropping below -125 degrees Celsius, -193 degrees Fahrenheit during winter, making insulation and energy production vital concerns. This massive impact crater, located in Mars's northern hemisphere, is filled with an estimated 2,200 cubic kilometers of ice. The crater's depth and geological formation help trap cold air, preventing the ice from sublimating into the atmosphere. This makes it an ideal location for resource extraction, though the terrain may pose challenges for construction and transportation. Mars is home to extensive networks of lava tubes, subterranean tunnels formed by ancient volcanic activity. These natural structures provide protection from harmful cosmic radiation and extreme temperatures, which could make them ideal locations for underground habitats. Additionally, they could serve as natural shelters against dust storms, one of the most significant environmental challenges on Mars. Currently being explored by NASA's Perseverance rover, Jezero Crater is an ancient river delta that once housed a massive lake. Its geological features suggest that it may have contained microbial life in the past. The region's diverse mineral composition and proximity to water ice make it a compelling candidate for future settlements. However, it remains uncertain whether sufficient resources exist for long-term habitation. One of the largest canyon systems in the solar system, Valles Marineris, stretches over 4,000 kilometers, 2,500 miles, across Mars. Some researchers believe that the canyon walls may contain water-bearing minerals and underground ice deposits. Additionally, the canyon's lower elevation means a thicker atmosphere, which could provide slightly more protection from cosmic radiation. The northern lowlands of Mars contain vast, flat expanses that may be well suited for large-scale construction. Some areas also show evidence of subsurface water ice, which could be extracted for human use. The relatively mild temperatures and open terrain make the northern plains a strong candidate for large-scale human habitation. As mission planners continue studying the Martian surface, new potential settlement locations may emerge. The choice of a landing site will ultimately depend on a balance of available resources, protection from environmental hazards, and logistical feasibility. Constructing a functional and sustainable infrastructure on Mars will be one of the most formidable challenges of colonization. Unlike Earth, Mars lacks pre-existing structures, making it necessary to build everything from scratch: habitats, power stations, communication networks, and life support systems. Martian habitats will need to be highly insulated, pressurized, and capable of protecting humans from extreme cold and cosmic radiation. Initial settlements may involve inflatable habitats transported from Earth, but long-term habitation will require structures built from in-situ materials. One promising method is using 3D printing technology to construct habitats from Martian regolith. Scientists are developing specialized concrete made from local soil and ice, which could provide a sturdy and radiation-resistant building material. Energy production will be essential for running life support systems, heating habitats, and powering equipment. Solar power is a viable option, but Mars experiences frequent dust storms that could limit solar panel efficiency. Nuclear power offers a more reliable solution, and NASA is developing small modular reactors that could be deployed on Mars to provide consistent energy. Wind power is another possibility, as Martian winds, while weak compared to Earth's, could still be harnessed for electricity in certain locations. Water is a fundamental necessity for human survival, and transporting it from Earth would be impractical. Fortunately, Mars has significant reserves of ice, particularly in its polar caps and underground deposits. Technologies like microwave-powered drills and electrolysis systems could be used to extract and purify water. Advanced filtration and recycling systems will also be necessary to maximize water efficiency, much like those used on the International Space Station. Growing food on Mars is another critical challenge. The planet's soil lacks essential nutrients, and the absence of an atmosphere means traditional farming is impossible. Hydroponic and aeroponic systems, which use nutrient-rich water solutions to grow crops without soil, will likely be the primary means of food production. Greenhouses with artificial lighting and climate control will allow for a steady supply of vegetables, grains, and even algae-based protein sources. Moving materials and people around Mars will require a reliable transportation network. Rovers and drones will be crucial for exploration, while pressurized vehicles will allow settlers to travel safely across the surface. Future advancements may include Hyperloop-style tunnels or magnetic rail systems that connect different colonies. Establishing a reliable communication network between Mars and Earth is vital for mission coordination and scientific research. Satellites in Martian orbit will provide data transmission, while local networks will enable direct communication between habitats. Latency issues due to the vast distance between Mars and Earth will require advanced AI systems to assist with autonomous decision-making. A well-planned infrastructure will be key to ensuring the long-term success of human colonization on Mars. As technology progresses, innovative solutions will continue to emerge, bringing humanity closer to establishing a sustainable presence on the Red Planet. Surviving on Mars will require a suite of advanced technologies designed to address the planet's harsh and unforgiving environment. From life support systems to sustainable energy solutions, These technologies will be the foundation of human habitation on the Red Planet. Life support systems will be crucial for maintaining breathable air, regulating temperature, and providing adequate pressure in Martian habitats. These systems will need to recycle oxygen efficiently, much like those used on the International Space Station, ISS. Technologies such as the Sabatier process, which converts carbon dioxide into methane and oxygen, and water electrolysis units that split water into hydrogen and oxygen, will be vital for maintaining air quality. Mars lacks a strong magnetic field, exposing its surface to harmful cosmic radiation. Protective measures will include radiation-resistant materials for habitat construction, underground shelters using lava tubes, and regolith shielding. Advances in bioengineering, such as radiation-resistant microbes or even genetic modifications, may also play a role in long-term protection. Sustained energy generation is essential for all Martian operations. Solar power, while a viable option, faces challenges due to dust storms that can obscure sunlight. Compact nuclear reactors, like NASA's kilopower system, may provide a more stable energy source. Additionally, experimental technologies such as fusion power and wind turbines, optimized for the Martian atmosphere, could be explored. Water will be sourced from ice deposits and hydrated minerals. Extraction methods may include microwave drilling and chemical extraction from the soil. Advanced filtration systems will be necessary to recycle wastewater, similar to those on the ISS, ensuring a closed-loop water cycle. Martian soil, known as regolith, lacks essential nutrients, making direct farming impossible. Hydroponics and aeroponics, which use nutrient-rich water solutions, will be critical for growing crops. Genetic engineering may also allow plants to thrive in the Martian environment. Future advancements in cellular agriculture could enable lab-grown meat as a protein source. Autonomous AI-driven robots will be indispensable for constructing infrastructure, conducting maintenance, and performing hazardous tasks. AI will also assist in medical diagnostics, research, and daily operations, compensating for communication delays with Earth. Developing and refining these technologies will be key to ensuring human survival on Mars. As scientific advancements continue, new solutions will emerge, bringing us closer to establishing a sustainable presence on the Red Planet. Surviving on Mars will not only test humanity's technological capabilities, but will also push the psychological and physiological limits of those who venture to the Red Planet. The journey itself, the isolation, the confined living spaces, and the physiological effects of low gravity all present substantial risks that must be carefully managed. Mars is, on average, about 200 to 25 million kilometers away from Earth. A round-trip communication delay of up to 44 minutes means astronauts will experience extreme isolation from their families, mission control, and society at large. Unlike missions to the International Space Station, where astronauts can return to Earth within hours in case of emergencies, Mars settlers will be entirely self-reliant. Being confined to a small habitat for extended periods with the same group of people presents significant mental health risks, including depression, anxiety, and social tension. Studies conducted in Mars analog simulations, such as the Mars 500 project and NASA's HISEAS experiments, have shown that long-duration isolation can lead to interpersonal conflicts and psychological strain. Developing robust psychological support systems, including AI-powered virtual companionship and frequent communication with loved ones, will be crucial for maintaining mental well-being. Mars has only 38% of Earth's gravity. Over time, this reduced gravity could have serious effects on the human body, including muscle atrophy, bone density loss, and cardiovascular changes. Studies on astronauts aboard the ISS who experience near weightlessness have shown that extended exposure to microgravity can lead to significant health issues such as impaired vision, weakened bones, and changes in fluid distribution. To mitigate these risks, astronauts will need to engage in rigorous daily exercise routines, similar to those practiced on the ISS. Resistance training, specialized Martian treadmills, and even artificial gravity solutions, such as rotating habitats, may be explored to help preserve physiological health. Cognitive decline due to prolonged space travel and isolation is another area of concern. A lack of new stimuli, high-stress situations, and disrupted circadian rhythms due to Mars' longer day-night cycle, 24.6 hours, could contribute to cognitive fatigue. Astronauts will require structured schedules, leisure activities, and possibly immersive VR experiences to maintain cognitive engagement and emotional stability. Developing comprehensive psychological resilience training, AI-driven mental health monitoring, and community-building strategies will be vital for ensuring that Martian settlers can endure the mental and emotional toll of life on an alien world. Questions of jurisdiction, governance, and resource distribution will need to be addressed before permanent settlements can be established. Beyond the logistics, the ethical implications of human colonization must be carefully considered. One major question is whether we have the right to alter an alien world. If life, however microbial, exists on Mars, what responsibilities do we have to preserve its natural environment? Scientists are still debating the extent to which humans should interfere with Mars' existing ecosystem, particularly in light of past mistakes on Earth, such as deforestation and habitat destruction. Another concern is the treatment of future Martian colonists. Living on Mars will be an extraordinary challenge, requiring strict discipline and resilience. Psychological and social structures will need to be carefully planned to avoid creating a scenario where colonists feel trapped in a hostile world with no way back. Discussions around labor laws, governance, and human rights in extraterrestrial settlements will become increasingly important. Technological breakthroughs on the horizon. Several emerging technologies could revolutionize our approach to Mars colonization. Advances in artificial intelligence will allow for greater automation in habitat construction and resource management. AI-driven robots will be essential for maintaining life support systems, mining resources, and monitoring environmental conditions. Another key innovation is bioregenerative life support systems, closed-loop ecosystems that use plants, bacteria, and algae to produce oxygen, purify water, and recycle waste. If perfected, these systems could significantly reduce the need for resupply missions from Earth. 3D printing technology is also expected to play a critical role. By using Martian regolith to print habitats, tools, and replacement parts, settlers will be able to build much of what they need without relying on shipments from Earth. Future developments in nanotechnology and genetic engineering may further enhance the ability of humans to adapt to the Martian environment. The timeline for Mars colonization. Predictions for when the first humans will set foot on Mars vary, but most experts agree that the 2030s are a realistic target. NASA and SpaceX are both aiming for a crewed mission in this time frame, with initial missions likely being short-term stays. Permanent settlements may take decades longer, potentially becoming viable in the latter half of the 21st century. Terraforming Mars, modifying its climate to make it more Earth-like, remains a distant goal, possibly spanning centuries. Some proposed methods include releasing greenhouse gases to warm the planet, or using mirrors to focus sunlight onto its surface. While these ideas are still theoretical, long-term human habitation on Mars may eventually lead to advancements that make terraforming a reality. Humanity's future as a multi-planetary species. Ultimately, the road ahead is not just about Mars. It is about the future of humanity. Establishing a sustainable presence on another planet will serve as a safety net for our civilization, ensuring survival in the event of global catastrophes such as nuclear war, climate change, or asteroid impacts. Moreover, becoming an interplanetary species will open new frontiers for discovery, innovation, and cultural evolution. Just as the exploration of Earth's continents shaped human history, our expansion into space will redefine who we are as a species. The journey will be difficult, filled with unknowns and unprecedented challenges. But as history has shown, the human spirit is boundless in its pursuit of knowledge and progress. The first footprints on Martian soil will mark the beginning of a new era, one in which humanity is no longer confined to a single world, but has taken its first steps toward the stars. The dream of reaching and colonizing Mars is no longer confined to the realm of science fiction. It is rapidly becoming a tangible goal within humanity's reach. As we stand at the precipice of interplanetary expansion, we must recognize that this endeavor is not just about exploration or scientific curiosity. It is about survival, progress, and the relentless pursuit of knowledge that defines us as a species. The journey to Mars represents one of the greatest challenges humanity has ever undertaken. It is a venture that requires immense technological advancements, unwavering determination, and global cooperation. The obstacles are formidable, ranging from the technical difficulties of interplanetary travel to the psychological and physiological challenges of living in an alien environment. Yet, as history has demonstrated time and again, humanity has an extraordinary ability to overcome adversity through ingenuity and perseverance. In many ways, the exploration and settlement of Mars serve as a litmus test for our ability to evolve beyond our home planet. Our civilization has reached a point where we can no longer afford to remain earthbound. The threats of climate change, overpopulation, natural disasters, and unforeseen existential risks make it imperative that we seek alternatives beyond our world. Mars offers us a unique opportunity to establish a foothold in space, ensuring that our species continues to thrive for generations to come. Beyond the practical benefits of space colonization, Mars represents something far greater: the embodiment of human ambition, the desire to reach new frontiers, to challenge the impossible, and to seek knowledge for the betterment of all. If we succeed in settling Mars, it will be a testament to our resilience, our ability to adapt, and our unwavering commitment to progress. However, the path forward will not be easy. Establishing a sustainable presence on Mars requires long-term investment, scientific breakthroughs, and careful ethical considerations. We must ensure that we approach this endeavor responsibly, taking into account the potential impact on any existing Martian ecosystem, the rights and well-being of future colonists, and the governance of extraterrestrial settlements. Collaboration will be key. No single nation or organization can undertake this mission alone. It will require the collective effort of governments, private enterprises, and the scientific community to pool resources, share knowledge, and push the boundaries of what is possible. The International Space Station stands as a testament to what humanity can achieve when we work together. Mars will demand even greater cooperation. Ultimately, the first human footprint on Martian soil will mark not just a milestone in space exploration, but a defining moment in our history. It will be the beginning of a new era, one in which humanity is no longer confined to Earth, but has taken its first true step toward becoming an interplanetary species. The road ahead is long, uncertain, and filled with challenges, but one thing is certain: our journey to the stars has only just begun. Thank you for joining us on this exploration of humanity's future on Mars. As we continue to push the boundaries of science and technology, we invite you to stay curious, stay inspired, and keep looking to the stars. The future is limitless. See you next time.